Well, welcome to our webinar on streamlined remote water level monitoring. Thanks for joining us today. We're glad to have you with us. We're going to try to answer all your questions, or at least as many as we can get to. So the first bullet here is for those that aren't hearing me, so probably not too relevant to most of you. This webinar is going to run for about 50 minutes with the bulk of that time, or about half, being available for questions. Maybe we'll get a little long-winded and not quite have a full amount of time for questions, but we'll stay on afterwards to answer as many questions as we can get to. If you do have questions, please type them into your control panel. You'll see a drop-down box for questions. Use that to enter your questions. And we are recording this webinar, so you can refer to it afterwards for reference. It's got a lot of good information. So just in the way of a quick introduction, my name is Paul Gannett. I'm the principal product manager here. I've been with Onset now for almost 28 years. I live here and work here on Cape Cod, where we're surrounded by water everywhere. We've got ponds, we've got streams, we've got estuaries and the ocean, and they're central to our economy as well as to our recreation. So I love water, and I'm glad to be here. I work over those 28 years. I've worked with engineering to develop our line of HOBO data loggers and stations for environmental and water applications. And back in 2005, I worked with the engineering team to develop our first water level loggers, and we've been working to expand that ever since. With me today is Mike Delellis. He's our senior technical support manager, and he is an expert. He's the man with all the answers, and he's been with us for 20 years. He started out building and repairing data loggers, which is a great way to learn what can go wrong with them. He's been with our technical support team since 2007. He's now the manager of our technical support group, and he loves data loggers.
Thanks, Paul. Yes, I do in fact love data loggers.
And in terms of topics for today, we're going to start out with some of the advantages of remote water level monitoring, and then we're going to go into some of the options that we have to offer here at Onset. And we have, and then Mike will be getting into some, sharing some of his expertise in deploying the HOBOnet water level sensors for, making it as easy and as reliable as possible. He'll share some applications, and then we'll have a chunk of time for answering your questions. So with that, I'm actually going to turn off my monitor. I don't know if you need to see me anymore. So yeah, in terms of what are some of the reasons that you might want to have a remote water level monitoring system? Well, here's just a list of the most common reasons. First, it's an easy way to be able to view current conditions and trends from wherever you are. In these days, with the internet access just about everywhere, we're just used to being able to check in on things wherever we are and make sure that everything's out okay. So same thing applies to your remote data collection systems. It's nice to see that things are okay. Another big reason for remote water level monitoring is it can save a lot of money in having to travel out to the sites to retrieve the data. You don't have to go out nearly as frequently. Another key advantage is alarm notifications. These remote systems can be set up to tell you when critical limits are reached, such as a certain level, water level for a flood warning application. You can also give you notifications when you get a certain amount of rainfall that tell you, oh, now you need to go out and take a water sample. And they can also give you a notification if there's a problem with your system and minimize the chance for losing data out there, because if you can get out there and fix it sooner, you're going to miss less data. So you can do things like sensor alarms, lack of communication alarms. There's several different types of alarms you can set up with a remote station. It also makes it easy to share data with other users. We have web services which allow you to programmatically share data with other programs. Because the data is on the internet, there's a lot of flexibility. We have public access screens, which you can share links to those. So it allows other users to view the current conditions at your sites. So by having the data up there on the internet, you've got a lot of flexibility in how you can share it. And you can, in our case, you can also add other sensors besides your water level sensors, such as rainfall, wind, and soil moisture, which are other measurements you may need in combination with your water level data. So it's nice having those options as well. That allows you to get a more complete picture of what's happening out there at your sites. So just some typical applications to help put this in context. I know probably most of you have your own applications in mind already, but here's some typical applications. Flood warning, which I mentioned previously. The alarm notifications are pretty important for that. And you also quite often need rainfall. Dam management, again, alarm notifications important for that. And you want to know sooner rather than later that you might have a problem. Wetland mitigation, we have many users doing this. And one of the big advantages of remote monitoring in this case is you can retrieve the data without having to go out into the site every month. You can go longer between your site visits. Stormwater management applications, irrigation management, aquaculture. I got a picture of an aquaculture application here, and included this because it's in Tasmania. I think anything in Tasmania is cool. Another reason for remote water level monitoring is some locations are just hard to reach. So by getting the data through the internet, you can get that data more frequently. So now I'm going to talk a little bit about some of our options we have. We have actually, because we've been in this water level business for many years now, almost 20 years, we've got many options that we offer for monitoring water level, both standalone loggers where you have to go out and retrieve the data. We offer a wide range of those, but we also offer several remote monitoring options, and that's what we're going to be focusing on today. So here's the remote monitoring options, kind of going from smallest to most comprehensive, going from left to right. So our simplest and least expensive remote water level station is the Micro RX water level station. That starts a little over $1,000. And all the prices that I'm using here are in US dollars. Your local prices, if you're in other countries, may be different due to import duties and other things, but this just gives you a point of comparison. So the Micro RX is a nice self-contained station, which can run a single water level sensor into it. And that price I gave you, by the way, is including the water level sensor and a cable. It's solar powered, the mounting's integrated, so it's the easiest one to mount. And you do have some flexibility to add external sensors, but in this particular case, you can't have a water level sensor and wireless sensors to the same microstation. So you get a little less flexibility. If you want more flexibility, then you probably want to step up to the RX3000 station. It's a little bit bigger. You need to have an external solar panel to power it. It's got more flexibility. You can have modules for connecting to things like analog inputs. It's got 10 smart sensor inputs for other weather parameters. You can connect wireless sensors into the same station, but it's a little bit more expensive, a little bit larger installation to do it. Then today we're actually going to be focusing on our HOBOnet sensor network, and that communicates with either an RX station or a RX 2100 station. And I'll talk a little bit more about that in the next slide. These are solar powered with little rechargeable batteries inside, and you can have up to 51 of these HOBOnet sensors in one HOBOnet sensor network, and prices start around $1,800 US dollars. And with these remote stations, all of them, you need to have a data plan. Those start at $199 per year, and all of them require 4G cellular communications for the central station. And so keep that in mind as well. So in terms of gateway options, so with the HOBOnet wireless sensors, you basically have a network that consists of a central station with a cellular communications, and then that can communicate with up to 50 wireless HOBOnet sensors in a mesh configuration. So the central stations have to be in an area where it's got that 4G cellular communications. The HOBOnet sensors could be positioned down in a valley where it might not have cellular coverage. I know that was one of the questions that came up in advance for those who sent you questions in advance, so thanks for sending those. The wireless sensors can communicate up to a station which maybe is at the top of a hill where it has better cellular coverage. So the primary difference between using micro RX as your central HOBOnet station and an RX 3000 as your central station is the micro RX is your easiest to mount. You can quite often mount it just on a PVC pipe, for example. It's pretty light, so it doesn't need a big fancy tripod to mount it. And it's also your lowest cost gateway option. Where the RX 3000 gives you a lot more flexibility. You can see you can connect up a lot more sensors and modules and things like relays. And but it does require a bigger, probably a tripod for mounting it, and it is a little bit more expensive. So those are your two main choices to choose from. So with that, I am going to turn it over to Mike to pick it up here. So let me give him control. Take it away, Mike.
Awesome. Thank you, Paul. Great insights. And as you were talking, Paul, I was trying to answer some questions that were coming in. So let me just get my screen up here. Hold on one sec. All right. So I think everybody can see my presentation here. Okay, great. So what I'm going to be going over is some deployment tips, some real world examples. I have some photos of those to show you all. And at the very end, I would not be doing my job as a tech support manager if I didn't go through some troubleshooting at the very, very end here. So most of what I have derived or what I've built into this is comes from our direct customers. When they call us, these are some of the questions that they ask and some of the topics that we discuss as we're working with those customers. So hopefully these deployment tips are very helpful for you. And one note too, if you've done these installations before, a lot of this stuff may be a review for you. But anybody new into this, this may be helpful. So let's get into it. Okay, so the first helpful tip I think I can give you is make sure that you do a thorough site survey prior to the installation of the RXW system. And by the way, most of my the information here will be focused on the RXW WL system here, and this is the remote water level monitoring system. So a site survey prior to the install is highly recommended. Couple of bullet points here. This is especially for anybody who's new to this. Know the scope of the work that you're going to do. Every installation is going to be a little bit different. Every site is different. Things to think about. Do you need to bring concrete in there to secure a post? Are you digging new wells? Things like that. Are other things maybe, do you need to procure some all-terrain vehicles to access sites and things like that? So every one of these sites is going to be a little different, and this is just some of the things that you want to think about. Know the terrain. Knowing the terrain is very important for the wireless range. Our devices communicate about 1,500 feet. That is line of sight. As you add vegetation and as you add different elevations and terrain, of course, it's wireless, so it will reduce depending on those type of things in those environments. And of course, if this is the first time you're doing it, I recommend bringing a few friends along with you to help you install these. Many hands make light work. I've installed a bunch of these myself, and the more hands you have and the more help you have, the easier it goes. Okay, just another helpful hint. So be familiar with the documentation. It's a good idea to sort of have some product knowledge before you get into this for the first time. So be familiar with the products. If you don't have access to the internet at the site, sometimes that happens, or at least it may be spotty in some cases. Go to the website, and print out the documents if needed. I have the 2 links here. One to the quick start guide and one is sort of the bigger user manual. And by the way, don't worry about writing any of those links down. We're going to send out this presentation in a day or so, so you'll have all that information for you. One thing I recommend to most everybody is to test the products before you install them. It's a good idea, even if you have a a small setup in even in a garage or out in the field by the office, just to give these devices a test run. It gets you familiar with the devices, and it will allow you to learn any sort of nuance that you might need to know in installing them. Now, that said, if you do have trouble in the field, contact tech support. Very highly talented group of folks that are willing to help you and here if you need us. So I'll have the tech support contact information at the end of this presentation. Okay, just another quick tip about tripods. So not everybody uses a tripod, but for those who are, this is basically the list of tools that you're probably going to need to install a tripod successfully. I'm not going to list out every single one here, but certainly take a look at this. Typically, a good mechanics set of tools will have all this stuff. One thing that I definitely recommend if you're installing these, especially if you're doing a lot of these, bringing a battery-powered screwdriver with the bit attachments for the tools that I'm mentioning above, and those sort of specifically those socket sizes, the 1/2 inch, the 5/16 and 7/16 deep sockets, if you can have them. It makes the installation of U-bolts and things like that go a lot quicker, especially if you're working with power tools. I've installed many stations, and the ones that I bring my drill along with me, they go a lot faster than if I don't. So good helpful hint. Okay, great. This next slide is just talking about the mounting bracket for wireless sensors. This is a super important piece of equipment that you definitely want to use. Each one of the wireless sensors, whether it's a remote water level monitoring device or if it's any other of our wireless sensors, they all come with this mounting bracket, and it's really imperative that you use it. On the left-hand side, I have an installation. This is an installation on my property. And you can see on the back side of the wireless sensor, I have that mounted to a galvanized pipe here. And I have that here with zip ties. It can be as simple as that. Yeah, this is a really good secure connection. One of the benefits of using this bracket is that you can securely tighten those brackets down. In fact, you can crank on them as hard as you want, and then insert the mounting or insert the sensor into that bracket. And that will prevent any over torquing to the sensor itself. Over torquing the sensor may cause case distortion and things like that, and that may cause it to leak. So using these brackets is great. You can securely mount the bracket, insert the logger into the sensor into the bracket, and then you just secure that down with a small screw. On the right-hand side, this is just sort of a high contrast version of it, just so you can see what it looks like. All right, so best practice for well cap setup. So here I'm showing 2 different examples of how you might use a well cap. This well cap that you're seeing here is the kind that we sell, and this would be a great well cap for a new well or a well that has a 2-inch or is a 2-inch PVC type well. On the left-hand side, you see where you have this is actually the connector piece that connects the sensor to the wireless transmitter, the moat, if you will. So on the left-hand side, you have an image of one where the connector has to be kept outside of the well. And this would be pretty common in a very shallow well where you may have too much cable and you need to get some of that excess cable outside of the well. So this would be a good installation here. So basically what you do is you route that cable through the top of that well cap on that plate up top there. And then the rest of the cable along with the sensor beneath it would sit into the well. On the right-hand side, we have one. This might be for a deeper well. This is great because you can use like a small carabiner. You can pick up those at any local hardware store. and you can actually clip it right onto the connector piece. And this is great because there's this is a really solid method to keep that sensor in that cable from slipping. So either one of these would work just fine. Okay, another popular topic that we talk with our customers a lot about, so reference level measurements. So I just wanted to spend a minute here and talk about what that is here. So referencing is this, you may need to compensate or in a sort of way calibrate the data on your logger here. So we'll go into a few examples here, starting on the far left. This would be an example if you are using a reference point. Here, the reference point shown is the very top of the well. It doesn't have to be the top of the well. There could be really anything. Perhaps it's ground surface. Perhaps you're installing this under a bridge and you want to know the distance of water between, the surface of water to the bottom of the bridge. It could be that. The important thing with this is when you take that measurement, that you enter that reference level as a negative number. And what that does is sort of inverts the graph, and it makes it so that when that water level is increasing, that distance between your reference point and the surface of the water it's showing that as a smaller distance, right? So again, we're the increase in water level would show in the data set as a decreased distance. In the middle here, we have a reference point that is, it's basically what we're showing here at the very bottom of the well, or this is almost in a sense ground surface. And that's your measurement there would be from the ground surface to the top or to the water level currently. One thing to point out in this type of reference level is the data logger can actually be really anywhere in that water column. You are effectively telling the data logger or telling the data that it is a specific measurement at this specific time, right? So we're showing it here at the very bottom of that well, but again, that logger can really be anywhere in that column. Again, you are telling the data what it is, and all of the subsequent readings from that point on will be reflected on the information that you enter there. The one on the far right here, so this is basically representing the height of water above the sensor. And this is actually pretty common. A lot of folks that, in my experience, that are doing this, they're really looking at water fluctuation. And so, having an accurate reference level isn't that important here. So you can basically drop that sensor in the water, and what's going to be represented in this case is the height of water above the sensor, right? Effectively, your reference level in there as measured is 0, right? So there's no you're not adding any offset. All right, jumping into the next slide here. So this is some reference level tips. This system's a little bit different than some of our other products if you're used to using, so for example, our U20 devices or even our MX 2001 devices. This is a little bit different. So a little bit of some high-level tips to kind of get through that. So after you've installed all of your sensors, the first thing that you want to do, if required, is add a multiplier. The multiplier is there for basically a water density change. And I've shown on the upper right-hand side here what the water density would typically be like for certain water types. So fresh water, there's no real need to alter the density. However, for brackish water and salt water, there is likely going to be a need to add a multiplier, and that's going to help you deal with a difference in water density. So we have some examples there. You can use those examples, or if you happen to know the water density, you can enter that in too. But again, if you're doing fresh water, no need to change that. So the second step here is to start the logger and wait a few minutes for the measurement to be made. It's usually 5 or 10 minutes and you'll have a measurement. I'd recommend keeping your mobile device open, looking at HOBOlink, and just keep on updating that screen, and you'll finally see a measurement. Once that's done, you have your logger or your whole system has a measurement now. Now you can take your reference level measurement. So you're going to take a tape or yardstick, whatever you're using to make the measurement, and you're going to take that as long as you have some data in the system. Now you can do that. And what you're going to do there is subtract that measured value, or subtract your reference level from the measured value. And then that's the information, that's the number that you're going to put in under the offset in the scaling window. And this is this screen that I'm showing on the lower right-hand side. This is if you were on the logger page and you click on the wrench icon, you can get to this screen. And this is where you enable that scaling. And as you can see here, the example I have is so I'm using a negative number here, so we know that's from a reference point, and the number I put in here is 0.95 feet. Now, so I did, just for sake of staying in time, I did sort of dumb down this a little bit. So there are also a little bit more details that you may want to review in the manual. So to get to those details, here's a link here. And again, just a reminder, you don't have to write this down. We're going to send this presentation out to you. Okay, so some helpful tips, protection from pests. Actually, one of our users asked a question about this. Hopefully this helps. So split loom tubing for large animals. I think the user asked about cows. However, I will mention that I've spoken with a lot of users that run into issues with deer, in woodland areas. So split loom tubing can help with this. For whatever reason, 9 out of 10 woodland creatures prefer the taste of our cables. So protecting those cables is a must, especially if you think you're going to have risks from deer, cows, any sort of animal that might start nibbling at cables. PVC conduit is another option for super high risk areas. It's a little bit more expensive and it's a little bit harder to install, but it's definitely there. It's something you could use if you need to. I've seen installations with that. In my opinion, the split loom tubing is good for about 99% of these types of applications, and that's available at almost all automotive supply stores, most of your sort of big box home improvement centers, and even your local hardware store may have this. You can also order it online as well. It's very, very cheap. It's probably pennies a foot to buy that stuff. Okay, next topic, consider mitigation for bugs. So, one of the things you have to think about when you're deploying these is, you are effectively bringing out a beautiful case, and bugs and things are going to find that very, very interesting and want to make that their home. Especially here in the U.S. in the southern states, ants and wasps can be a pretty big problem here. So, what I'd recommend here, if you think this is going to be an issue, there are lots of different states have different regulations with type of pest control. So not a bad idea. If you think this is going to be an issue, if you're not able to attend to your sites often, then consider working with a local pest control expert. They should be able to help you think of ways to keep bugs out of these things. Okay, another helpful tip, site visit maintenance items. One of the things, this is a remote monitoring station. However, every now and then, it's not a bad idea to check up on that station. So you may want to consider scheduling visits now and then. Some folks go out once a year. Some folks, they're maybe closer to it and they go out a few times a year to check on these things. So one of the things, I have this image here on the right-hand side. This was actually a weather station in the back of our facility in Bourne, Massachusetts. It was a sort of a station that got forgot about here. Well, Mother Nature, like always, wants to take things back, right? So that's sort of happened here. We did end up clearing this out, and the station has been moved, so it's okay now. While you're there, you want to evaluate the need for new reference levels, right? We talked about taking those reference levels earlier. It may be a good idea to drop down a tape again just to make sure everything still looks right, and then make adjustments as needed. As I pointed out here, keeping vegetation in check around stations and monitoring wells is pretty crucial. I mean, the good news is that usually Mother Nature will take it back, but it doesn't take it back that fast. So you have some time here. But while you're there, keep things in check. Also, solar panels, make sure you keep those clean. Those solar panels, their job is to keep the batteries inside these devices charged. One of the things when you're installing these, you're giving the birds a beautiful place to perch on. So, if you're heading out to the site, bring some cleaning supplies so you can wipe down those panels. And then lastly, check for damage from pests and vandalization. Pests, I've talked about a couple times here, and definitely can be an issue. Vandalization, not as much, but if these are deployed in urban areas, that is something that can happen. In fact, I've even seen it in very rural areas as well. So just something to keep an eye on. Also, Paul mentioned the alarming features. If you get an alarm, all of a sudden things aren't connecting. That's something to think about. It could be damage from pests or vandalization. Okay, so and folks, and forgive me if I'm going a little too fast. I do want to make sure we get through all our slides and leave enough time for questions at the end. But okay, we'll get into this one. So this is some real world HOBOnet water level deployments. So here's some photos. These are actually from customer sites. They were very kind enough to allow us to use these photos. So we'll start from the left and work to the right. On the left, you see an RX 2100 data logger that's mounted on a PVC pipe that's securely mounted into the ground there. And you'll see the RX manager or the RXW manager that's at the very top of that PVC pipe. One thing to point out, and I'll talk about this a little bit more with range. The higher you can get the wireless sensors, the better they will communicate. Especially when if you're dealing with a lot of vegetation. In the center here, this is something that you may encounter. So this is an existing steel well, and it was sort of, they installed a similar PVC pipe behind that to mount the wireless transmitter there. But in this case, that sensor is inside that steel well. Also, very acceptable way to use these things. And let's see here on the far right, we have an example of a new well installation. And here you can see that well cap that I showed in a previous slide. And that's on the left-hand side here on a 2-inch well. And then just to the right of that, you see again that PVC post with that transmitter right on the top there. And again, that's to try to get the longest range you can out of these devices. Actually, this photo on the right sort of illustrates why height sort of matters here. You can see the vegetation is if you get lower on that in that photo there, you can see that vegetation gets relatively thick. So to be above that is your best bet. Okay, so I just wanted to illustrate the mapping features of HOBOlink. So I have two different examples here. One on the left here is a relatively complex system. In fact, you can see the amount of devices that are connected to this one system. So I'll sort of explain what you're looking at here. In the very center, you see the blue square, and that's the data logger. So in this case, the user placed that data logger into the location they know that they mounted that. And then those subsequent little looks like upside down water droplets, those are your RXW wireless sensors. So there, and here the user is also placing those all over this field in this installation site. And so what this is showing you is how these devices are actually connecting back to the actual logger head. That's sort of the brains of the operation, if you will. The HOBOlink map feature is also great for troubleshooting in the event that you have some outages or some of these sensors go down. This is a good way to quickly visualize where the problem might be and where to start investigating. I know here in the tech support department, we often go to this map right away to start troubleshooting connection issues. On the right-hand side, this is a little bit simpler of a setup here. On the lower right of that image, you see just a small system with two RXW modes there. The system above that is slightly more complex. The difference, I'm not sure if you can see my mouse here. These devices that I'm circling now, if you can see my mouse, it's sort of that's got the one with it looks like a transmitter in the middle. That represents a repeater. So it's not really a sensor other than I think it measures temperature, but it's just a repeater. It's there. It's something that's helping to relay information from the moat that's right behind it, which is this one just to the left of that. So you can quickly identify what is what by looking at that. Also, on a real system, you would notice when you hover your mouse over these, some information would pop up that is helpful for you to identify which device that is. Okay, great. So just some quick troubleshooting tips. I want to start here. So there's multiple parts to this system. So I wanted to first start with the RX remote station. So this pictured on your right-hand side there, this is the RX 3000 series. This is sort of the bigger of the two devices you might be working with. But this is the logger head. This is the brains of the operation. This is what's sending all the data up into the cloud. So one of the things that you may encounter is having trouble getting a connection to HOBOlink, right? So if you were calling the tech support department, one of the first things that we're going to ask you is, is the station registered on HOBOlink? Or do you even have a HOBOlink's account set up, right? So maybe you're just setting this thing up. So that's one of the first things we're going to ask you. Make sure you have all that stuff in order. One of the next things we'll probably ask you is, do you have cellular service at this location? In a lot of rural areas, there are some spotty connections. And I noticed there's a few questions about spotty connections here. So one of the things to know is the logger, it is required that the logger has self-service in order to upload this data to the cloud. So that said, a lot of times within your deployment, you will find a spot that does have at least spotty service, right? So in that location, this logger will operate okay. You may experience missed calls here and there, but at least for the most part, you'll be getting your data up to the cloud in a timely fashion. For example, if you're in a location where the logger needs to be, just based on that site, try moving that logger up a little bit higher. That will help with the connection to the internet. One thing that we experience every now and then, so these are battery-powered devices, and it's very easy to plug in the solar panel and forget to plug in the battery. In fact, with the logger on the right-hand side, the RX 3000, we ship that device with the battery cable in back. So for a new user, they might not know that's there. So if you are having trouble with connections, make sure the battery and the solar panel are both plugged in. And if you're in an area with spotty connection and you're setting these devices up and you want to just make sure that you're getting data to the cloud, just try pressing the cloud button. You'll see the image on the right. There's actually a little button there that above that looks like there's a cloud. So during the installation of this product, if you're in a spotty area and you need to get data up there, hit that cloud button. It's sort of like when your call drops, you just make another phone call and it goes through, right? So not too much different there. And then that last bullet point, if this logger all of a sudden, after working for a long period of time, stops working, it may be necessary to get out to the field just to make sure there's no damage to the logger. Okay, so we'll jump over to some RXW sensor connection issues, right? So we'll just kind of talk through this. So if you're first setting up this station, one of the first things that we're going to ask you in tech support, if you're having trouble getting modes to connect to the system, so we're going to ask you, is the RX station in search mode? There's a button on the logger's LCD. It's a magnifying glass. When you're first setting up this system and you're getting modes to attach to the system and actually upload data, that's important that the system is in search mode. One of the other things we're going to talk about if you're contacting support on some of these issues is if you're having connection issues, what does that terrain look like? If you remember in the beginning of my presentation, I talked about a site survey. This is sort of why it's important for you to know really what you're dealing with there. So the terrain, is it a hilly terrain? Is there a ton of vegetation in the way? One thing that I've always noticed is that very dense pine forests tend to be some of the hardest things to actually get a signal through. So if you're in that situation where you have a really thick pine forest, then that might be something to consider, right? So these devices will communicate through that, but you just might not get the full range. So you may have to utilize repeaters or at least orient your devices in a way where they can talk to each other and relay that information. In some of those cases, if you raise or even tilt the RXW moat in a situation where the terrain is uneven, if you have one moat that's connecting to another moat that's at a higher elevation. So it may be necessary to actually tilt sort of that outside moat, right? So tilt that towards so that it's sort of facing that that other moat that it's trying to connect to. And again, I mentioned earlier using that maps feature to help you sort of realize or help you understand where the connection breakdowns might be. And that's important sort of when you're setting these devices up. You know, it's definitely, I would recommend using that map. It sort of helps you know where everything is. And if you're adding those moats to the map as you go, it makes it a lot easier. And again, I mentioned earlier as well, having a second set of hands or a few folks to help you out doing this type of troubleshooting is always good to have. Now, I'm sure everybody's wondering what that massive apple is doing on the right-hand side here. I put that in there for a reason. So that apple actually represents the broadcast pattern of a wireless sensor. So basically the colors here kind of represent it's sort of its strong points, right? So that deep red outer edge of that apple, if you almost think of it as the equator of the apple, that's your strongest broadcast point. And that's where, you know, so that's sort of where that line of sight comes in. That's where it's going to broadcast the most efficient. So then as you go up, the colors, basically as you go up to the top of that, you'll notice those colors sort of turn yellow and then green and blue. And those points are basically getting a lot weaker there. If you were to mount two wireless sensors, you know, one on top of the other, you would not be able to get the full distance there, right? Just because they broadcast outward versus in a sort of a circle, if you will. If you were to look at this image from the top down, it would look very much like a donut, right? So the system is broadcasting outward. Okay, hopefully we've left enough time for some questions. It looks like we have too, so great. Hold on one second here. Let me see if I can find a few questions to answer here.
So maybe while Mike's looking, I'll start in. I have been answering some of your questions in the chat box, so hopefully you're seeing the answers to those. One of the questions that came up in a couple of different from a couple of different folks was connecting water quality sensors that we don't offer as part of our system. And what I wanted to just kind of highlight there is in the RX3000, we have an option for an analog input module, which has, I think it's 4 analog inputs. And those can be connected up to water quality sensors that have analog output, such as a 4 to 20 milliamp output. And one of the vendors that we commonly refer our users to is Phionics, and I included a link to that in the answer I sent via the chat. And they make water quality sensors for like pH and DO, and what else? There's another one, connectivity, that can be connected into those analog inputs of our RX3000 station. So that's an option to keep in mind for sensors that we don't support as part of our system, that you can connect them in through the analog input. So you got one? Find a good question there, Mike? I'll turn it over to you.
Yeah, it's sort of a high-level question here. So we have a user here asking what the difference between the RX station and the MX stations are. It's a great question, especially if you're new to Hobo and what we do here. So I'll start with the RX stations. You know, the RX stations are basically your remote type station. They communicate via cell. They're typically used, I'd probably say historically used for like weather station type parameters, temp, RH, wind speed. And over the years have adapted into other things, and sort of, you know, where we landed here with this remote water level station. Now the MX series is more of a standalone data logger, most often used without sort of a cloud connection. We do have a MX gateway which gives you that connection, but for the most part, our MX users, they'll deploy these, you know, for example, in well, I'll use a water level example here, our MX 2001 devices. So it's going to go into a well where it is, it doesn't necessarily need any sort of telemetry. You're just, but you're going to schedule a time to go out there, maybe on a quarterly basis, to download that data. So yeah, that's probably the biggest difference between that. Is that, sort of cloud-based and standalone.
All right, I'll take the next question. One of our users was asking, are these suitable for drainage control structures? And the answer on that is yes, as long as you can get the cabled water level sensor down into the drainage control device, you should be able to use these stations just fine for monitoring your water levels within the drainage control device. So sometimes people will want to install a PVC pipe in either like stormwater drains or in the drain control structures to just kind of protect the cable and sensor in there. And you just need to have some holes or slotted PVC down in the water so that the water can easily get in and out of that PVC pipe. So the answer is yes.
Great. Now we have a question here. So how can you even out small fluctuations caused by barometric pressure? So these devices, it's all compensated within the device itself. The measurement, or the transmitter head has a barometric sensor inside, and so basically what's happening there is it's measuring differential pressure, and that's in conjunction. So basically, the barometric pressure sensor and the water level sensor are working together in that case. So we're already compensating for barometric pressure.
Let's see, there was one. Oh, here, I'm going to go to one of the questions that was sent in advance. So thanks to those of you who did send questions in advance. Some of those questions we covered during the presentation, we just kind of worked them in. But this question is what is the reporting sensitivity, feet, inches, millimeters? And the sensitivity or resolution depends upon the sensor you're using with the system. So we have 4 different sensors with 4 different ranges. For the finest resolution, you'd want to use our 4-meter sensor, and that has a resolution of 0.005 feet, or in metric that would be 1.4 millimeters. And then the accuracy on that is 0.01 foot or 3 millimeters. So hopefully that answers that question.
Awesome. Let's see here. There was another one of those pre-submitted questions. I sort of covered this a little bit, but I like to get people thinking on this thing. So the question is, if all of our field sites are way out in the wilderness, what's the best way to set up? So just to get everybody sort of thinking about that. I've spoken with a lot of users, some that are doing exactly that, some that are installing in urban areas, and certainly, there may be a need in some of these cases to procure an all-terrain vehicle. Maybe you have to rent one of those things when you get to the site. If it's relatively local, maybe it's a resource that you may already have. In some cases, I've even seen folks, they actually hike it out, right? So they hike out these systems. It can get pretty heavy, right? So that's some of the things that you just want to consider while you're, and again, another reason why that site survey and really knowing, what the scope of the work is, before you set out to actually install the system. So I sort of touched based on that before, but I like to bring that up again just to get people thinking about what they may have to do to get these stations installed.
So another question we have is somebody looking for general tips on deploying loggers in stormwater systems and utilizing weirs to calculate stormwater flow. And for that, what we'd recommend is one of our RX stations with the wired water level sensor. Those sensors can be used in combination with what do we call it? It's basically a data assistant within our HOBOlink software, which can convert the water level data associated with that weir to flow data. So it supports several of your standard weir types, V-notch weir, for example, or rectangular weirs. And you can use our software to calculate what the flow is when the water level is a certain level above that that weir. So that's only with the wired sensors. Our wireless sensors don't actually support that feature now. But that's a good question.
Awesome. User here asks if biofouling is an issue. So yeah, I guess that's sort of general answer. Yes, almost always. Now the sensors themselves, it's a ceramic sensor, and it's a stainless sort of housing, if you will, and it does a pretty good job at resisting a lot of things there. But every now and then, especially if you start noticing some drift or something like that, some sediment that may have been built up or something like that, every now and then, again, it's one of those site maintenance items I probably could have actually added to that list is, clean off any biofouling. To do that with these sensors, I typically recommend soapy water. That we usually, and just kind of flush it out. And if it's really bad, maybe a little bit of vinegar in there as well.
Okay, I'm seeing a question here on, I have a sensor that reads 0.02 even when we know it's empty. And what that means is you got to remember with our sensors, there are actually two sensors. There's a barometric pressure sensor that's in the air, and then there's a water level sensor that's in the water. And to calculate water level, we calculate the differential pressure between those. And sensors are not perfect, so they might have a little bit offset one way or another. By entering in in HOBOlink, you can enter in the what do we call it, the offset, and that can calculate that out. So if you're reading 0.02 in the air, when you know that it should be reading 0, what you just do is add in an offset of minus 0.02, and that will compensate out that little offset error. That's normal to have to calibrate your pressure sensors like that.
Just bear with me one sec here. I'm just kind of looking for some sensors that we can answer here.
Yeah, well, Mike's looking. I see another question similar to the one I just answered. He said sometimes the water level appears to drop below the bottom of the container. Again, that's because of those little offset errors.
Let's see here. Let me go back into the preset questions here if we have anything we missed.
Yeah, these are all good questions.
Yeah. We did have a question here about a little bit of detail on the broadcast pattern. We have your information. I'll probably reach out to you. I may have some questions of a little bit more detail about what you're asking here, but so I'll reach out to you directly on that. That's for James. Let's see.
Here, I just wanted to add that for those of you who sent over, interest in connecting sensors that we don't, have right now, such as, LG sensors or, thanks for sending over those. I do work closely with our engineers to develop new products, so it's always good to know what sensors you'd like to see us support, and hopefully we can add those sensors over time. So thanks for those inputs.
Gotcha. And actually, in a similar fashion here, so we have a user asking if the RX3000 can connect directly to so an RJ type Ethernet connection or a BACnet type connection. So the answer, currently at this point, so these devices are cellular only. But this is great information. We, if we get a lot of requests like this, that's something we investigate for a future enhancement. Let's see, Paul. There was some things I think that you answered in the text here. I don't know if we want to maybe reread some of those or.
Yeah, I'm not, to be honest, I'm not sure exactly what you guys are seeing on the other end. So yeah, maybe it probably would be good to answer some of those questions just to make sure that everybody gets those
Sure.
answers, because we've got a couple more minutes here.
Yeah, so I just want to touch base on one real quick. So we had a question here about leaving an RX station in the window, and and will that actually help charge? Or will that actually allow the device to be recharged? So Paul answered yes, that'll work, and yes, absolutely. All sorts of different types of installations to sort of get the data that you need, right? So that very well may be the loggers inside the house, right by a window with some sunshine, and yeah, I've seen that work. It should be okay.
We also had a few questions on the range. So the range, line of sight range is, we say 1,500 to 2,000 feet. Of course, that range between sensors gets reduced if there's any obstructions in there. If you've got trees and stuff in there, that range can easily get reduced by a half. And we do sell repeaters for our wireless sensor network to help you, maybe get around some of those obstructions and extend your range. And you can have up to 5 what we call hops from your central station out to your furthest sensor. So you can basically get 5 times 2,000 feet in your ideal conditions.
Nice. Another one. A user asks if what happens if the batteries are not charged for, let's say, 6 months. So it sort of depends, right? So there's a lot of things that go into the to how long your battery will last without a charge. How frequent the device is connecting to HOBOlink or uploading data. Sort of inside of that is what's your cell strength. So believe it or not, if your cell strength is really good, you'll use a little bit less power. In places where the cell strength isn't as good, there's some gain that gets adjusted to try to compensate. How many sensors you have attached, in terms of for example, smart sensors, that'll definitely, the more you have there, the more the battery can be consumed, and also how much data the device is processing. So if you have a massive system with 50 modes, that could be, that's a lot more work for the logger to do. So that would probably decrease how long that can go. Now that said, I mean, so I know it's sort of a wishy-washy answer, and I apologize, but anywhere from I'd say anywhere from 30 days to probably several months, depending on those things.
All right. Well, Mike, I think we're just about, we've covered most of the questions that are of general interest. There's a few specific ones we'll want to follow up on, but
Sure.
maybe at this point, you want to close us out?
Yeah, absolutely. So yeah, thanks again, folks, for attending. So just some real quick, some contact information, how to get a hold of us here. So if you want to talk to one of our product application specialists, and maybe you're interested in purchasing some of this equipment, give us a call or hit us up at sales@onsecomp.com. If you have this stuff already and you need some help, as I mentioned earlier, we have a very talented staff in our support group that is always willing to lend a helping hand. Contact us through the web there. There's your link, onsecomp.com/contact/support. Also available on our website, live chat. That's a great tool if you're in the field and you just need a quick question answered, right? So use that live chat. With that said, thanks everybody for joining us.
My thanks as well. It's been a pleasure.
All right, take care, folks.